Hi everyone, welcome back to the Code2Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by the Google Developer Groups at VIT-AP. Now we've already completed 16 days and we are moving to the 17th day. So let's start with the first problem. So coming to the first problem, we are given with reversing a singly linked list. So coming to the description, we'll be given with our head as the input. Then we should reverse the entire list and then we should be returning the head of the reversed list. So yeah, as I told, the input would be the head of the current list. So coming to the test cases, we'll be having our input of 10, 20, 30, 40, 50. So this is a linked list. So we have to reverse this. So the linked list would be 50, 40, 30, 20 and 10, and then we should be returning the new head which is 50. So when we traverse through the entire linked list, we'll be having our output like 50, 40, 30, 20 and 10. For the input 30, we'll be having our output 30 because if it's a single element in the linked list, then it would be the reverse of itself, right? So if the input is null, then our output will be null because there are no elements in the linked list to be reversed. So if the input is 10, 20, 30, 10 and 20, we should be reversing this linked list and we'll be having the output 20, 10, 20, 10. So this 20 over here, this 10 over here, this 20 over here and this 10 over here. Now let's look at the two approaches. So coming to the approaches, we'll be given with our linked list like this. We'll be given with the head. Then the head will point out to the entire linked list. So initially we'll be having a linked list like 1, 2, 3, 4 and 5. We should traverse through the we should reverse the linked list. So we should be making it 5, 4, 3, 2, 1 and we should be returning the new head which is 5. So how can we do this? Let me give you a hint for the brute force. Let me start with the brute force or the naive approach and let me give you a hint. So we have to reverse these values, right? We should be having 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5. So what can we do? Can you think of a data structure which will store these values, and when we want to remove the values from that data structure, it will give us in the reverse order. So if we store the 1, 2, 3, 4, 5, we want our outputs from the data structure like 5, 4, 3, 2, 1. Can you think of a data structure like this? All right, let me tell you. If we store 1, 2, 3, 4, 5, we want the outputs. We want the elements from the data structure like 5, 4, 3, 2, 1. Think of a stack. So what if we traverse to this linked list storing these values in a stack? So the first element would be 1, then 2 above it, then 3 above 2, 4 above 3, and finally 5 above 4. So 5 will be the topmost element. So if we remove the elements from the stack, we'll be having our elements in the order 5, 4, 3, 2 and 1, right? So what can we do? So we can traverse through the entire linked list storing the values in the stack. Then instead of creating a new linked list for placing those values, we can traverse through this linked list itself, updating the values, right? So after traversing, our values in the stack would be like 5, 4, 3, 2 and 1. So traverse through this linked list only again, modifying the values. So the first node will be having the topmost element of the stack, which is 5, and 5 is removed from the stack. The next node will be having the second topmost, so it will be 4, then 3, 2 and 1. We can return the previous head itself as we are not updating the head. So this is the previous linked list itself but with updated values. So I hope you got the first approach. Now let's look at its code. So first thing, we should be creating a stack which will be storing integers or the values of the linked list. Next we should point a pointer towards the head so that we can traverse through the entire linked list. So till the temp reaches null, this will be executed. This will stop when the temp reaches null. Temp is the pointer, right? So this will stop when the pointer reaches null. So first thing, we should be placing our value in the stack, then move it to the next node. So we'll be placing 1 in our stack, move the temp to 2. 2 is not null, so we'll be placing 2 in the stack, move it to 3. 3 is not null, place 3, move to 4. 4 is not null, place 4, move to 5. 5 is not null, place 5, move to next one. Here temp equals null, temp becomes null. So this while loop stops its execution, and we have our values 1, 2, 3, 4, 5 in our stack respectively. So next, coming to traversing once again, just make this pointer point to the head once again. So we'll traverse to the entire linked list once again, modifying the values. See, first the temp would be over the first node. Temp's value equal to stack.pop. So temp's value should be updated to the topmost element of the stack. So this should be 5, this should be 4, this should be 3 as well. I mean, in this was previously 3 as well, but now also it's 3. This should be 2, this should be 1. So we'll be popping the elements from the stack and placing them. So our linked list will be finally like this: 5, 4, 3, 2, 1. So we can return the head as we are not making any changes to the head, and it was previously over there itself. So if we return our head, our code is done. We'll be having our output like 5, 4, 3, 2, 1. But now let's discuss its time complexity and space complexity. Its time complexity would be around big of 2n. Why? We are traversing through the entire linked list once and twice. So we are traversing through the linked list. Let's assume this linked list has n nodes. So the time complexity would be 2n because we are traversing through it twice. And the space complexity would be big of n. For storing the value of n nodes in the stack, we'll be storing 1, 2, 3, 4, 5, right? So the space complexity would be around big of n. So yeah. Now let's come to the better approach, or the optimized approach, or the general approach. This is what generally people do while solving reversing the linked list. So let me explain. So assume this is our initial linked list, and after reversing the linked list, we'll be having our output like this. So this is our head, and after completion of the process, this should be our head as well. So now let's come to the approach. We'll be needing 3 pointers. See, we'll be needing 3 pointers. The current should be pointing towards the head, and the next 2 should be null. So let me explain why. This is our head, right? So what did I say? The current should be pointing over here to the head. So what can we do? We somehow want this one to point to null, right? This should be pointing to null, and 2 should be pointing to 1, but not 1, but 1 should not be pointing to 2. So what can we do? Let's do one thing. Let's call the next of current to be front. So make the next of current, so front equals current dot next. So this is our front, right? Initially front was null, but now we are calling the currents next to be a front, and previous was initially previous equal to front equal to null previously, initially. Now the current should be pointing to previous. Let's go through a few steps to understand this. So the next step would be current dot next should be previous, right? Let me explain why. So if the current dot next equals previous, what are we telling? We are telling this pointer should point to previous, which is null. Now the current, alright, now the previous should be made equal to current. So this will become the previous, and the current should be equal to the front. These are the 4 steps which clearly explain this reversing the linked list process. Let's do the let's do it step by step for understanding it more. So let me explain it properly. So these are the 4 important steps. So you understood this, right? So now the current is over here, current is not over here. The current will be made equal to front, right? The current will be over here. Now what did I say? As I told previously, front should be equal to the currents next. So front will be moved from here, this is current, and front will be moved to here. Front equals currents next, so front will be over here. Now currents next should be previous. So currents next is not pointing towards 3 anymore, it will be pointing to the previous. And now the previous should be made equal to the current. This node is not previous anymore, but 2 is. Now the current should be equal to the front, so the current will be moved to here. This is not our current anymore, right? Now similarly, if we perform these 4 steps, see, as you can see, our first 2 nodes are reversed. Similarly, if we perform this till the end, our entire linked list will be reversed. So let's perform these steps. Front equals currents next, so front should be moved from here to here. Currents next should be previous, so currents next should be pointing towards previous, and previous should be moving to the current. So this is 2 is not our previous anymore, but 3 is. Then the final step, current should be equal to front. So let's move our current from here to here, right? So similarly, front should be sorry, what did I write? It should be current, right? So similarly, front should be moving to the currents next. So our front should be moving from here to here, right? Now currents next should be pointing to previous. So currents next should not be pointing towards 5 anymore, it should be pointing to the previous. And previous should be made equal to the current. So this should be the previous right now, and this is not our previous anymore. And the current should be moving to the front. So this will become our current, right? Now 5 is pointing to null, right? As it was initially the last element, it will be pointing to null. Now front should be moved to currents next. So let me draw this over here. 5 null, this 4, and it is pointing to something else. This was our previous, this is our current, and this is our front as well. Now front should be moved to currents next. So front will be moved to null. So this is not a front anymore, our front is over the null. Next step, currents next should be pointing towards previous. So currents next should not be pointing to null anymore, it should be pointing to the previous. And the previous should be made equal to the current, right? Previous should be made equal to the current. So previous is not this anymore, but our previous will be over here, right? Next, current should be moving to the front. This is not our current anymore, and current will be moving to the front. So current is at null, front is at null, and previous is at the last node. So we should stop this process. When should we stop this process? As soon as current reaches null, we should stop this process, and previous will be at the last node. So our linked list will be like this. 5 is pointing to 4, and which is pointing to 3, which is pointing to 2, 2 is pointing to 1, and 1 is pointing to null. So we finally reverse the linked list, and our previous is at the last node or the head of the first node. So we can reverse our previous, we can return our previous. We should be returning the head of the reverse linked list, which always will be previous. You can consider a few other cases as well. The previous will always end end up being at the head of the reverse linked list or the last node in the initial case. So we can return previous, which because it's the new head, the head of the new linked list or the reverse linked list. So this completes our code. So I hope you got the explanation how this, by doing this, was brought to this. So these four steps are crucial. So these four steps are what is over here also. Current should be made to the head, previous should be null, friend should be null. As I told, till the current equals null or till the current does not equal null, we should run these four steps. First one, friend should be equal to the currents next. After that, currents next should be pointing to the previous should be made the current, and current should be made the friend. Then finally we can return previous as I told. So coming to the space complexity and time complexity of this, so we are only traversing through the entire linked list once, right? And there is no extra space being used. We are just using pointers which will take constant space and will not be using much of our space. So the time complexity would be big O of n and the space complexity would be big O of 1. So the interviewer will be happy with this, and because the time complexity is big of n and space is big of 1, there is another approach using recursion, but the time complexity and the space complexity will be the same for the recursion as well. So if you are interested, you can go through the recursion process as well, but the complexity stays the same. So, and it's much complex than this method or the previous one explained. So I hope you entirely understood how to reverse a linked list and understood the time complexity as well. So this brings us to the end of the first problem. So thank you. Let's move to the second problem. Thank you.